Alright folks, I'm going to talk to you about a brand new set of numbers that you've never heard of before. And generally this doesn't go so well the first time, so hopefully I'll help you figure this thing out. Let me just start with some basic ideas here first of all. When we first started with numbers, we started with numbers like 1, 2, 3, 4, and so on. And these numbers were great for keeping track of how many horses I had, how many pigs in the stall, those kinds of things. But as just only this group of numbers, there became a problem. Somebody says, well, what happens if I don't have one of something? What happens if I have none of something? So someone said, hey, wait, we got to change that number system and include 0. So it went from what were called the natural numbers, which is just 1, 2, 3, 4, 5, and so on, upgraded to something called the whole numbers that included a 0. So along came somebody and said, hey, this is a good set of numbers. And they said, well, wait a minute. What happens if I, borrow $2 and I end up having to pay back $3? And they say, what kind of number do you get then? And you're like, whoa, I don't have that kind of number. So they said, we better make negative numbers, meaning you have less than you began with. And so someone said, well, let's add in the negatives, and off we go. Those guys began to be known as the integers. So do you see how we're building on number systems? And then along came someone, and they said, well, what happens if I divide one of these by another? And so let me get myself a little space here. And they said, what happens if I take a number like 5 and I divide it by something like 2? And they said, ooh, what do you get then? We don't get 1, we don't get 3, we get something in between. And they said, we need a new number system. And they called that the fractions or the rational numbers. Well, pretty soon somebody says, well, what do we do with this? Like I get this. This is easy. We got numbers like that, but what kind of number is this? And that created problems. Well, I guess what I'm trying to teach you is that at each stage, number systems have grown to be able to solve new types of problems. And we are at a stage now where we need to solve a new type of problem. And up to this point in time, you have believed that this is an unsolvable problem. So this should be an interesting moment when I introduce this to you. But I think if I asked you, what's the answer to this? You would kind of laugh at me and say, there is no answer. And you'd say, why isn't? And I'd say, why isn't there an answer? And you'd say, well, when you take the square root of -1, there's no such number that can multiply by itself to obtain that. 1 times 1 is 1. -1 times -1 is 1. This is an impossibility. Well, today it is no longer an impossibility. We're going to expand our number system to something even bigger than the real numbers. Now, the real numbers are the guys that you've been using for years: square roots and fractions and negatives and integers and whole numbers and all of those things, decimals and repeating decimals and all that. Well, all of that included a lot of numbers, but it did not include your ability to take the square root of -1. So what we're going to do is define a brand new thing called I. And what I is it is exactly the square root of -1. So wherever we see the square root of -1, we can alter it and change it to I. Let me show you what I mean by this. So let's go back to the question that we just were talking about. If I take the square root of both sides, so let's say I take the square root of this side and also the square root of this side, I get x equals plus or minus the square root of -1. Now the square root of -1 is exactly I, and so I can write this as plus or minus I. My two solutions to my quadratic problem are plus and minus I. Let's try this again with a similar but a little bit different question. Let's take the square root of -9. This gives you x equals plus or minus the square root of -9. Now let me break out the negative 9 for us a little bit. Let me break it into the square root of 9 times the square root of negative 1. This is still just the same number. See how those all multiply to be the same? But something quite nice happens. We get plus or minus 3i. This is our solution set. To see how the 9 became this 9 became the 3, and this square root of 1 became this I. And so this is a way to obtain answers, and in this case the two answers would be plus or minus 3i. Let's look at some more. Alright, let's solve these two. So I like the idea that I would take the square root of both sides. This leaves me with x plus 1 on this side, and over here it leaves me with plus or minus the square root of negative 3. So I'm going to leave x plus 1 alone, and I'm going to split this into the square root of 3 times the square root of negative 1. So I again split it up into its pieces, and now watch how nice and easy this becomes. I get a little plus or minus 3i, and then I move over my 1 to the other side. This is pretty complex looking stuff. Hey, welcome to the name, complex numbers. A complex number often will have a real part and then an imaginary part. Let's do this again. You'll kind of see it form. Again, I'm going to begin by moving the 4 over to the other side, becomes negative. I'm going to take the square root of both sides, and in doing so, I get x minus 3 equals plus or minus the square root of negative 4. Let's keep going a few steps, going in small steps. The square root of 4 times the square root of negative 1. And what happens quite nicely? The square root of 4 becomes 2, the square root of negative 1 becomes I, and I have my final answer, which is 3 plus or minus 2i. Now that's a very cool answer, and it's not that much harder than what we were doing. But you can see here's the real part of my complex number, and here is the imaginary part of my complex number. So this is how we work with imaginary values when we can now solve things that have the square root of a negative number. Very cool stuff. Good luck with it. So I guess finally I just want to say that a complex number has kind of two parts to it. The first part is kind of our real numbers. This is like what we're used to. That can be like negative 3, or it could be 2/3, or it could be the square root of 5. The back part is the part that's got the imaginary part. That's what I means, is imaginary. A very cool name for a type of number. And this might be, 3i or negative 5i or whatever. These are the kinds of things that would show up as a complex number. So let me just show you a couple examples. So 5 minus 2i is a complex number. Negative 6 plus 2i is a complex number. The square root of 5 minus 2i is a complex number. Again, it will always kind of can have two parts, a real part and then an imaginary part. It could also just have an imaginary part. It could just be 5i, for instance, and what really that means is that you have a 0 value here, but we don't write the 0, we would just write the 5i. But these are called complex numbers, and we're going to learn a lot more about them.